So we are in the context of zero-shot learning. We want to do entity linking using zero-shot learning. So the only thing that we have is entity descriptions, because for unseen data, we need entity descriptions. These are valuable things. So I want to focus on this important paper in 2019, zero-shot entity linking by reading entity descriptions. So this is the architecture that we have a couple of, so we have all entities in the entity dictionary, like burden could be, the surface shape could have a different entities. For example, in UMLS, for each one we have a CUI, so we should know which concept we are talking about, because there are more than 3 million concepts. The main motivation for this study is to expand the scope of entity linking and make them generalizable to unseen entity sets. The important thing in zero-shot learning is just like this. Therefore, we drop the above assumption, make one weak assumption that the existence of an entity dictionary. So we assume that we have the descriptions of entities. And our goal is to build entity linking that can generalize to new domains and entity dictionaries, which we term worlds. We define a world, mention, and entities. And for dataset construction, they construct a new dataset to study the zero-shot entity linking using documents from Wikia. There is our community-written encyclopedia, each specializing in a particular subject or theme, such as fictional universe from a book or film series. And we need candidate generations because we need top K entities and retrieve the top K entities, for candidate ranking, they use BERT as well. And they use pool transformer to represent a sequence of tokens, a sequence of embeddings, and adapting to the target world. We focus on using unsupervised pre-training to ensure that downstream models are robust to target domain data. There exist two general strategies for pre-training: task adaptive pre-training and open corpus pre-training. We describe these below and also propose a new strategy: domain adaptive pre-training, which is complementary to those existing approaches. So this is task adaptive pre-training, that they're pre-trained on the source and target domain unlabeled data jointly with the goal of discovering features that generalize across domains. After pre-training, the model is fine-tuned on the source domain labeled data. But there is another approach, open corpus pre-training. Instead of explicitly adapting to a target domain, this approach simply applies unsupervised pre-training to large corpora before fine-tuning on the source domain labeled data. Examples of this approach include Elmo. I've explained Elmo last year. And so adapting to the target world. In addition to pre-training stages from other approaches, we propose to insert a domain-adaptive pre-training stage where the model is pre-trained only on the target domain. So U denotes text segments from union of source world documents, document distributions, and U target denotes the text segments from document distributions of a target world. And combining them denotes the randomly interleaved text segments from both source and target.